Welcome to Walkabout the Galaxy, the actual astronomy faculty astronomy podcast, where the science is universal, the opinions are personal, and the sponsor is grown old.
Oh, no.
No?
No.
You might
I'm not sure what that means.
You might change your mind when you hear the sponsor, Eddie. We are Strange Charm Top the Astrocorps, also known as Josh Cole, Eddie Dove, and Jim Cooney, coming to you from the Walkabout studios at the University of Central Florida. Walkabout listeners, stick around till the end of the show to find out about new ways to connect with the Astrocorps and get your burning questions answered. YouTube videos and cool WTG shirts.
Yeah, you definitely don't want to hold
gear.
on to burning questions. That could be painful.
That's kind of related to our
Oh man, I'm
sponsor.
so good today.
Jim,
Yes, sir.
Moo Moo or Ubuntu?
What?
I figured you would know both of these since you're a Scrabble expert,
Uh,
and these are unusual words with use.
they are. They are.
Which you'll see why.
I think a muumuu is a ridiculously comfortable outfit,
True.
so I'm going with that.
Okay.
Okay.
I would if I could wear muumuus and it was
Ubuntu is
socially
a-
acceptable for me to come and teach in a muumuu, I would.
I think you should do
I'm
that.
going to get a poll and show to you
I
that
think
it is
will be
socially
socially
acceptable.
It is socially
to do
acceptable?
that, yeah.
And so
Alright.
then you will be obliged to
I
teach
will
in a muumuu.
absolutely teach in a muumuu.
You heard it here first, everybody. Jim
Dr.
Cooney
Jim
will
Cooney.
teach
They look so
Will be.
comfy.
introductory astronomy
I'm
in a
gonna
muumuu.
buy you a muumuu.
That's right.
Spelled, and how's it spelled? Scrabble.
I don't know. I
Yes,
don't know.
yes, you do.
M-U-M-U?
Yes.
No.
I don't think so. That's not an acceptable
It's
Scrabble word.
M-U-U-M-U-U.
Yeah,
Oh, because it's a
yeah.
Hawaiian word or something.
Yeah.
It
So,
is.
but the reason why I wouldn't do
Maybe
that
it's
in
pronounced
Scrabble,
You can't do that in Scrabble. There's not that many U's.
there's 4 U's. You could do
Oh.
it, but it'd be very unlikely. So
To
it's,
come up.
yeah. M-U-M-U, if it would also be reasonably unlikely. There are only 2 M's.
So then you should have chosen Ubuntu, which only has 3 U's.
That's so,
It would be more likely
Both of
to come
them?
up.
I guess
Yeah.
MUMU would be mu instead of
I don't
mu.
know.
And the Ubuntu you could make from bunt might be already there. And
Ooh.
slap an extra couple
2
U's
U's
on
on
there.
there. Just slap some U's on
unluckily
there.
placed, but possible.
What kind of show is this again?
Scrabble.
All Scrabble all the
learning,
time.
apparently, Yeah.
Addie, monolith or regolith?
Regolith.
Okay,
It's
wow.
not even a question.
Really?
All right.
Yeah.
Well, it's the 50th anniversary of 2001, as I've mentioned a few times
Yeah, but
before.
regolith is one of my favorites.
Are you saying that if we
shows.
found a giant monolith on the moon, that you would still be more interested in
Then
the regolith?
That's right. She's
Yes.
So
like,
this is
ooh.
the dirt?
Yes.
You want to dig around in the dirt?
She
All
might
right.
be.
I
She'd
do.
be like,
Alright,
ooh,
fair
that's
enough.
tiny.
You know what that monolith might be made out of? Regolith.
3D printed on the moon.
Yeah.
The aliens sent a 3D printer to print out their giant monolith
Yeah.
out of
Mm.
regolith.
That's what we're working on is 3D printing technologies using
Yeah.
resources
I
locally.
kind of have a feeling the monolith might not be 3D printed.
I also feel like if this really happened, she would be more interested in the monolith. But, since it's not real, I think regolith.
I might be interested in how the regolith interacts with the monolith.
You might be. You might be.
Osiris Rex is approaching Bennu.
Yay!
Ooh.
Hayabusa 2 is hanging around Ryugu.
I see a theme.
And New Horizons is almost to Ultima.
Ooh.
So there's a lot of U's. There's a lot of U's.
There are a lot. That is a lot of use.
So that's why-
And Ultimate Tool is also MU69.
That's right.
Wow.
That's right.
Mm-hmm.
So there's a U theme and one
And
of
you.
an MU theme,
Mm-hmm.
and one of our items to report is there's been some news stories about a new paper discussing Oumuamua,
Oh my
not
gosh.
to be
3
confused,
U's.
So many U's.
not to be confused with Moo
No.
but very similar,
Ubuntu.
and also Hawaiian in origin. I think the word
It is.
Oumuamua means scout.
Mhm. Like Sky Scout, you think, or something.
Something like that. So Oumuamua was this object discovered interplanetary in origin. There's a new paper about that we'll talk about. Another paper about dust moons.
Yay! I don't know.
Combining
Would that
two
be?
of Addie's favorite things.
Yeah, would that
Yeah.
be more
Moons and
interesting
dust.
to me than the real moon?
I should have
Let's
asked
find
that.
out.
I should have
Let's
asked
find
that
out.
question. But we'll find
Stay
out.
tuned.
Yeah, plus space news and trivia. But first, and all will be made clear in a moment, this episode of Walkabout the Galaxy is brought to you by Uranus. No groans. Uranus is
We're
big and
just
blue
shaking our heads at you silently.
and colder than you might expect. Uranus has several narrow rings around it. Uranus is filled with a lot of methane gas, and wind at Uranus blows as fast as 900 kilometers per hour. Uranus has an unusual tilt that is probably due to something smashing into Uranus a long time ago. But Uranus is more than just the butt of astronomy jokes. Get it? The butt of
I
astronomy
didn't get
jokes.
that, but thanks for repeating it so that I did.
You're welcome. The seventh planet from the solar system, Uranus, has 27 moons, at least, which are named after characters from Shakespeare and Alexander Pope.
It's so classic.
That is
Its
awesome.
moon Miranda, though tiny, has world-encompassing grooves and giant cliffs suggesting it may have been broken up and reaccreted in its past. So don't forget to check Uranus before you head out of the solar system on your walk about the galaxy. I'm very sorry.
Not sorry.
I am very sorry.
You're not
I
sorry.
am sorry.
This is
Uranus had been asking to sponsor the show for a long time,
Okay.
and I had refused, but
Close-minded.
they
It's hard to
increased.
say no to Uranus for very long.
That's true. When it's demanding something,
Yeah.
you've got to pay attention. And I could not ignore it.
Oh gosh,
All right.
this show is going down the gutter.
Yeah. Down the gutter.
Well,
Yeah.
somewhere.
It's going
That's where we
somewhere.
talk about it going.
Well, last time we were talking about three-way alien sex.
We were.
And the Oumuamua thing has to do maybe very, very tangentially with aliens because
Yes.
Wow. Good transition.
it was on this. It's from another system. It's from outside our solar system.
Right.
And we know that based on its orbit, it has too much energy to have originated inside our solar system. And there was something funny about it. A lot of people were like, ooh, maybe it's interstellar craft, and it's got this funny elongated shape, although we don't really know too much about its shape. So I don't think we have pictures of it. That's an important disclaimer, I think, because there's a very famous, suggestive artist rendering of this thing going around.
Right.
We don't really know what it looks like, but we do know that in bulk, it's long and skinny.
So
Which-
just to
which-
refresh our memories.
Which
Which?
is reminiscent of a giant alien space station in the classic Arthur C. Clarke novel Rendezvous with Rama. Arthur C. Clarke, also author of 2001, which I also earlier referenced. In
Wow. Way
Oh,
to tie things in.
everything's
Very nice.
Such.
All right.
Used and 2001 are just blowing around all over the place.
Yes, Jim.
I was just going to refresh
Rant
our memory.
away.
We've no, I'm not ranting just yet. I will rant later in this
Yes.
episode, I think, about
Great.
several things. But we were prompted to talk about this today. We talked about Oumuamua when it first came around last year. So this was in 2017. It came through our solar system as the first thing that we had confirmed that was from outside of our solar system, visiting the solar system.
Very exciting.
Very exciting. It was very cool. We talked about it. I'm not sure at the time, though, we mentioned one of the coolest things about it, because I don't remember talking about this.
Oh.
Was the fact that it had this kind of anomalous acceleration. That is, it was, as it was heading, it came in close to the sun and then was heading back out toward the sun and going very quickly, and actually going more quickly out of the solar system than we calculated it should, based on normal orbital mechanics like the sun's gravity and even the gravity of the planets.
Yeah, so there's a lot of debate about, was it an asteroid, was it a comet, what kind of body was it?
Right.
as
What was
coming
it, and why
through?
did it have this? And there are plenty of reasons why things might have an acceleration that's not exactly what you'd calculate from orbital. Anyways, there are
What-
things
like
on
what?
the surface, like if it's a comet,
Oh, it's outgassing.
right? A comet's outgas, and
Yes.
and they outgas on the side that faces the sun preferentially, and so they get pushed away from the sun. And so, but we did not find any evidence of outgassing when we actually looked at the object, and so.
Which would have shown up as like emission from gas.
Right.
So emission lines in the spectrum
Right.
near the object.
Right, and we saw nothing like that, which means it's mysterious. And so we're prompted to talk about it again today because just last week there was a paper published by a couple of Harvard astrophysicists, which of course means must be right, that suggesting that this object may well be an alien spacecraft or probe of some kind. Now, since that publication, a lot of other scientists have kind of cried out and say, hey, you probably shouldn't jump to that conclusion.
Yeah.
I remember when I first saw this was like front page news on even CNN, like the day before Election Day, when it was dominated by, and it was still on the front page of CNN, and I thought, wow,
Aliens
that's
are
kind of
interfering
crazy.
with our elections.
The next, and it was just like, yeah, alien, this thing might have been an alien ship. And then the next day it said, this thing might have been an alien ship, but most scientists say not. They finally did not.
But
Yeah.
my favorite thing about a lot of those headlines too is not my favorite thing, but is that like oftentimes it's like scientists say, blah blah blah.
Right.
It's like, well, one scientist is saying this, or
Yeah.
a group of a few of them are, and it's an interesting hypothesis. But so the authors of this study also have been putting out a bunch of sort of astrobiology, sort of life elsewhere in the universe hypotheses recently. They put out a
Right.
bunch of articles about like how life may have formed and evolved and over time, and where else it might be in the universe and things like that too.
But what's the essential calculation or measurement or observation from their paper? It can't just be, hey, there's an unexplained extra acceleration, therefore it could be aliens. That's the end of your paper there.
I think that's the paper.
Did they rule out anything else? Or, I mean, of course, it could be.
It could be aliens,
space
right? No, I mean, it was
craft,
based. I think it was. They specifically were talking about solar sails, which is a thing that we have started to do here on Earth now. Use radiation pressure from the sun to push craft, and so they did some calculations of. I guess they did some calculations that suggested that the acceleration of Oumuamua is consistent with a solar sailed ship.
Well, okay.
And, and because we can't find any other really neat, tidy explanations for its acceleration, they jump to this. Now, of course, good scientists usually don't jump to kind of out there
Like aliens?
alien solutions
Yeah.
this early in the game. There's still, I say this early in the game, we're not going to get any more information about this.
Right.
No, and there's also very few observations about it because
Right.
it came and went very quickly.
It came and went very quickly. We saw it, and we're not going to get any more observations. It's
Yeah.
gone.
Right.
And
It's still observable. It's a super, super faint object. It doesn't disappear from view, but it's just a dot of light.
right.
Yeah.
Our observations are getting worse and worse and worse. We're getting less information. So
We probably get like some light change based on not even
We
that.
may have.
And we won't be able to see it for super long. So.
Right. No, it disappears. I think it goes below magnitude 22 or something in a year or two. It's an incredibly, incredibly faint thing already.
Right.
And so we're not going to learn really anything more about it.
Right.
I'm not disagreeing with that.
right, unless it turns around and comes back.
Then
Because it's
But
an
then
alien
it wouldn't be
spacecraft.
solar sails either.
No,
that
that's not how
would be
sails
pretty
work.
suggestive, though.
Yeah, that would really do it.
So the solar sail idea is pretty cool, though, because, I mean, not as it pertains to Oumuamua, but in general as a thing.
Right.
Which is using the momentum delivered by actual light from a star
Right.
Mhm.
to accelerate your spacecraft. And of course, as you
Did
get
they model the Yorp effect on this asteroid?
I think they did. Yeah, I mean, they tried all these things, the Yarkovsky thing, and all. They tried a bunch of things, and
so Yorp and Yarkovsky are other sorts of ways that the motion of an object is affected just by the energy of light from the sun.
right.
It causes the rotation to change a little bit, can cause the orbit to change a little bit from these very, very weak forces of one side of you is a little bit warmer than the other side, so it's emitting a little bit more light than the other side, and that actually makes, over long periods of time, measurable differences in real asteroids in the solar system, which is kind of mind-blowing.
It is
Mhm.
mind-blowing.
Yeah.
But I think those things are fairly, have been reasonably well ruled out as the primary
Right,
thing here.
because they're so weak forces that
Yeah.
it takes a long time to build up, and if you're an asteroid zipping around the sun over and over and over again, then after a million or a billion years, some interesting things can happen. But this thing was in and out of the solar system in days. Well, not the whole solar system in days, but in terms of being close
Right.
to the sun,
Right.
A very short period of time, less than a year. So, so there are been historically some observations of things having unexplained accelerations. There was this
Right, what's the famous one?
is it Pioneer?
Yeah,
Mhm.
yeah, there's a
Yeah.
thing called the Pioneer Anomaly,
Anomaly,
right?
yeah.
Right. So the Pioneers were the very first deep space probes that went.
What a great
right?
name for them then.
Yeah.
Yeah.
They were launched in the 70s and headed out of the solar system, flew by Jupiter and Saturn, and Pioneer 10 and 11. And we've been, as we have with the Voyagers, been able to monitor, or we're able to monitor the radio transmissions from them. And because those are a particular frequency, you can see the speed of those spacecraft very, very, very precisely. And they were showing something not agreeing with what Jim coined, I thought quite cleverly, as norbital mechanics.
Normal
Normal orbital mechanics,
Norbital mechanics.
which shall forever forth be known as norbital
Norbital
mechanics.
Did I say that?
Sounds like
You did say
sounds like somebody
Oh.
named like Norm or Norbert named it.
Orbital Mechanics.
Isn't it Norbert, the
Norbert.
little guy in Futurama?
It's also going to be the name of my firstborn child.
There you go, Norbert.
You heard
It
it here
sounds
first.
awesome.
It's not going to be
Did you-
Wally? I thought
You're
Wally
gonna be
was
Wally.
your
No,
ultimate name.
I don't know.
Did you know that?
Well, it can be a middle name.
Did you know that Marco A and B, the little two CubeSats that are out at Mars that went with InSight to Mars, which we actually got some images back from them recently.
From the CubeSats?
CubeSats?
Mhm.
Nice.
That's pretty cool.
But they're not named Marco and Polo, which would make the most sense. They're informally named Wally and Eve.
Oh, nice.
Huh.
Very nice.
Okay, anyway.
They're going to name, they're tiny little cute things, they're going to name them tiny little cute names.
Mm-hmm.
So
that
you,
makes sense.
you should have a boy and a girl and name them Wally and Eve.
All right. I'll get to work on that.
Okay.
Anyway, Oumuamua and Norbital.
Orbital Mechanics.
Mechanics.
So the Pioneer anomaly.
Oh yeah.
So that, I guess, has so that was
It's
something
more
that we
recently
worried about for a very long
resolved.
time, but I guess we've finally kind of resolved that, and it was the thing that Josh, you just mentioned, this kind of anisotropic radiation pressure thing. That is, it's not radiating its light equally in every direction, and therefore it gets an extra push because it's radiating more light in one direction than the other direction. But again, this is a thing that built up over years and years and years,
Right.
whereas this Oumuamua thing is a matter of days.
And it was measured at a much higher precision than we could measure for Oumuamua.
Right, because we're receiving.
We're not like looking at a dot on a grainy photograph moving across.
Right.
Well, I guess not grainy photographs anymore. It's digital detectors. Not to date myself too much here, but you get a much clearer, more accurate measurement of an object's velocity if you're measuring a radio transmission from that object and seeing how the frequency changes.
Right.
Which is not the case with Oumuamua, unless it's an alien spacecraft sending
There were
messages.
people looking for radio signals from it
And they
when it
found
happened, and they
none.
did not
Did
find
not find
any.
any. Oh, were they looking in the right frequencies?
I don't know. I'm sure they
Mm.
swept a range of frequencies though.
Speaking of looking for alien life,
Mm-hmm.
there's a new story from a friend of the show, we can say Mike Wall, our
Oh,
guest
yes.
from last episode, on
On
space.com about the Breakthrough Initiative.
Oh yeah. So which the Breakthrough Initiative is this idea, is this Breakthrough Listen, they have the Breakthrough Listen project and a bunch of other things where that's sort of like well-off people who want to do big things can fund these initiatives to find alien life, basically, or to advance space travel in general, I think, is a lot of it. And to find ways to do breakthroughs in space science and technology and other things. So they have the Breakthrough Listen project, which is trying to fund listening for aliens, right? And they have the Breakthrough Starshot, which was the light sail project they wanted to do.
To send a CubeSat-sized thing with a
Mhm.
light sail and propel it by
to like
a super
Proxima
powerful laser.
Centauri. You shoot lasers at
Awesome.
And you get it going
This is the
super
future.
fast, right? You get
Yeah.
it going. You get it 4 light years away to the nearest star in like 25 years or
it
something.
so fast.
Yes.
Which is, it actually is really fast.
Is this reasonable? Is that going to happen?
So
I've been hearing
there's
about
a
things
lot
like
of
that for a while,
problems
but
with it
is it-
because you have to be able to like
It has to
Accelerate
stay
it.
stable, right? And
it
like
has to stay stable. You have to accelerate it and like I guess you have to do a lot of the acceleration pretty early on because your lasers aren't going to work.
I don't know. Sounds awesome though.
But
So-
they have a new thing.
A new thing on
Something.
Breakthrough Initiative. So they announced on this last week winners of the Breakthrough Prize, and there were several $3 million Breakthrough Initiative prizes related to astronomy.
Mm-hmm.
But as it relates to search for life, they're talking about potentially funding or helping fund missions to look for life at Mars, for example.
Mm-hmm.
So sort of a different tack from the search for extraterrestrial intelligence. It's looking at our backyard, which NASA has been doing in a sort of incremental fashion, right, over the years, and
Right.
sending missions to Mars. And there's some evidence that there may once have been
Yeah.
water on Mars.
What?
And maybe even at the present day.
Maybe
Wow.
we should talk about that next week
Yes.
on Walkabout.
Yes.
Yeah, but this stuff is pretty cool because, so, you know, when the government spends money on these things, they generally have to be really careful. And they spend a lot of money to do, like you said, kind of
Risk mitigation.
incremental things. Whereas private money,
Breakthrough is not incremental.
Right.
No.
Yeah.
By definition.
Private money, they can be very risky with it, and they lose it, and it's okay. So they're thinking about missions to
I don't know if it's
Europa,
okay.
and
They
they're.
may not be okay.
I mean,
with
what? Yeah, sure, but
it's
it's a higher risk reward thing, and they're much more willing to take these big risks
Right.
because the rewards could be so great. So they're thinking about things like Europa or Enceladus or other places where.
icy moons where there may be
icy
life.
moons and the atmosphere of Venus and things
Right.
like that, where there are places that there might be life, but NASA's not really looking at that in the near term.
There's some calls for a Venus cloud orbiter thing in some of the planetary field things.
It's gonna
but
take a while.
It takes a long time to develop that technology.
And a lot of this cool breakthrough stuff is cool because it's picking up some of the slack. And like the government used to fund SETI, for example, quite significantly, the search for extraterrestrial intelligence, listening for alien signals. And eventually, when 30 years passes and you haven't heard anything, then NASA stops funding it. Yeah.
Looking for that. Right.
But that's where some of these people, billionaires, step in and spend some of their money looking for it, continue the search because they realize, if we did hear something, it'd be friggin' awesome.
And one of the big proponents for the Europa mission recently was not re-elected. So there's a lot of questions about where
What's
that
gonna happen?
initiative is going to go in Congress.
So there's 2 Europa missions. We should clarify. One is well underway, the Europa Clipper, which is a Jupiter orbiter on an orbit orbiting Jupiter. How many times can I say
Interesting.
Jupiter
Is
orbiter?
it a Jupiter planetary orbiter?
It's a Jupiter planetary orbiter orbiting the planet Jupiter.
Interesting.
But on an orbit around Jupiter that flies by the moon Europa multiple times.
You know
so
what
it's-
Jupiter and Europa have in common? A U.
You! Oh my gosh!
Which brings us to our trivia question
No way!
for today. We have a U theme going today. And there is a type of spacecraft called a U-class spacecraft.
In real
Letter
life?
U. In real life.
Okay.
In
There's
the life
also like
that we're-
U-boats.
That's true. I could have done a U-boat trivia.
Those are watercraft.
But as this is the actual astronomy faculty astronomy podcast,
It's
thought I
really
would
long.
do-
Can we make an acronym out of that?
it might be not repeatable.
AAFAP. I don't know.
U-class
Aft.
spacecraft are better known as. You're gonna guess it, Addie.
I am?
Yeah.
Okay.
What kind of spacecraft are?
CubeSats.
Yes.
Oh, nice!
CubeSats.
And since you and I are both leading CubeSat missions from here at UCF, and we have a U theme going, today's trivia is about CubeSats.
I feel left out.
You
Go
can
ahead.
have one, Jim.
It's okay.
So,
I haven't built any.
Jim, you're gonna have
any
to.
CubeSats
You'll
yet.
give when we come to the answers. You're gonna give your guess first.
Okay.
Because Addie's probably got a little bit of an edge on you. This one.
Fair
Okay,
enough.
we'll
We do
just
know
see.
a few things about CubeSats.
So CubeSat mission, CubeSats. It's CubeSats are these spacecraft in different sizes that are built in units called imaginatively.
A U.
And a U is about the size of a Rubik's cube. 10
It's a
centimeters, 10 centimeter cube, and about
Bigger than a
one.
Rubik's Cube.
It's a little bit bigger than a Rubik's cube.
I always say it's like a single size or a small Kleenex box,
Yeah.
and then a 2U is like a normal size Kleenex box.
That's better. And the CubeSats range for the purposes of this question, from a quarter of a U
Whoa.
up to 27 U.
Oh, do I know the answer to this question?
I
Can I
don't
talk
know.
about some of the quarter of U ones?
Sure, you can.
I'll do it after the trivia
But the
question.
question is just how many have been launched, how many have been destroyed on launch, and how many are planned to be launched in the next 6 years? And the answers to these came from a European database of nanosats that's pretty awesome, that has your satellite,
It does.
and it has mine, but it's more exciting for yours because yours is
I love
actually in
it.
space.
Yay!
And it has a picture.
It's
If
got
you're-
it's got a picture from like a super old presentation I gave at like the one we did in England in London.
Oh, way back.
I need
It
to
looked
send him like or maybe he updated it
It might
recently.
be updated. It looked
Okay.
like an actual photograph that might
Oh.
have been.
I'll have to check it out.
It looked like an
Is
actual
it Gunter's
photograph.
Space Page or one of the other ones? Because there's
It's
a good
European.
one called Gunter's Space
It's
Page.
dot
also.
.eu.
Yeah. Okay.
So that'll be your question. Straightforward trivia, but about these little tiny.
Straightforward, but hard.
Well, you don't. It's not. It's easy to understand what the question is asking.
Yes.
Which is not always the case. I have to admit for
Yeah.
some of the
The
trivia,
nanosats.eu database.
probably.
They have lots of good graphics that I've used in a
Right,
few
but you can't
talks.
cheat and check your answer
I
now.
was gonna look at Surfsat, but I'll wait.
Yeah, you have to wait. So,
Surfsat also has a U in it.
so some of the other news we were talking about that was U-themed has to do with these missions that are approaching various U-named bodies like Ryugu and Bennu and Ultima. Somebody has to tell us how to pronounce that.
Ultima, I think it's Ultima Thule.
I want to say Thule, but I don't know why.
I don't think it is.
I bet it's Thule.
I kind of want to say that too. But
Anyway,
we don't know.
we don't know.
We don't know. So
We're not that bright. What are you gonna do?
if only there was
should
some
ask
way to
Alan
find
Stern.
out.
You would tell us.
He will tell us. I will ask him,
Okay, great.
and I'll post it.
Great.
So coincidentally, we have spacecraft that are approaching several small objects that coincidentally have U's in them, and two of them are having major events right at the end of this year, 2018, beginning of the next year, 2019. So New Horizons, working from the outside in.
Yep.
Is the
It's
spacecraft
MU-69.
that flew by Pluto and is going by this other object in the Kuiper Belt, and it's going to go zipping by that thing. I spoke to Alan actually on the phone just recently, name dropping, about the encounter and was asking about what kind of data we'd be getting back and when we'd be getting it.
Yeah,
But it's so
that's a
far
good
out
question.
there, and it goes zipping by this thing so
Mhm.
fast. Of course, it's not going to take time while it's zipping by to
Yeah.
turn and spend time transmitting data back
They
here.
spent a lot of time before the Pluto encounter, like mapping out the exact sequence because they have to have it all planned way far in advance, and then they've been doing all of that for this next one as well.
Right, they do
Lots of
rehearsals
time,
and the whole
yeah.
flyby thing because so the last
Timing is critical.
image that they get before it goes into the full encounter, the last transmission that they get before it's like, okay, I'm not talking to you again until after I'm done flying by this object.
Can't talk to you. I'm doing science.
I'm getting ready. Because the last image they'll get, he said it'll be 3 pixels across.
Whoa!
Yeah,
It's far out
yes.
still.
It's tiny, this thing.
And then is
they're
that like 2
moving
days
super
before or
fast.
something?
Yeah, it's just a week
Yeah,
before,
that's
something
crazy.
like that. So it'll be 3 pixels across, and then it flies by, and it'll be, something like 2 days
Okay.
before we have
Anything back?
awesome pictures back. I
So
think
exciting.
there's a hello, everything, I did what you told me to do.
I was a good spacecraft.
I was a good spacecraft, and I took all the pictures you told me to take. That information will come on the 1st of January 2019.
Is this largely just imaging, or do they have other instruments that they're
It's all
gonna
the
plan?
They've got
instruments on New
multispectral
Horizons.
imaging, and they have some fields and particles instruments, and they have a dust detector.
Okay.
But usually the dust detector is turned off during certain operations. They have specific nodes that they do because the different instruments point different directions. So
Right. Dust detector was built at University of Colorado
student dust
from the
detector.
group that Addie was in before she came here.
It's named after Venetia Burney, named after the girl who named Pluto.
Right.
Yeah.
So that approach is coming up. As was mentioned in our last episode, OSIRIS-REx, we're getting some amazing pictures.
It's about a
of-
month out from Bennu
Right. So it's arriving at the end of the year, and it's already
or
taking.
Ryugu. It's hard to tell which.
Yeah, right. It's arriving towards the end of the year, but we're already getting some really beautiful resolved pictures of Bennu.
It's got some sweet regolith.
Addie likes dirt. You should see her place.
Oh, word.
So-
I like regolith, not dirt.
Bennu is got this funny diamond shape.
Dude, so does Ryugu.
Yeah.
Why?
They look very similar. It's a great question why. It's probably
Thank
Thank you.
Great
because-
answer.
Thank you very much.
There's a great answer.
So it's
why.
mostly because they're very like loosely held together bodies. They're called rubble piles. And as they rotate, they get sort of smooshed at the equator, and so they get this little what's called
The-
equatorial bulge.
The rubble rolls
Ooh,
downhill.
bulge.
And yeah, it creates different gravitational potentials on the surface, and you get a downhill
There's
motion.
one big
maybe.
boulder on Bennu that I really want to
Just like
flick it off.
pull it off.
I want to go up and just tap it.
It's
And
like-
it wouldn't take much to make that thing go away
No,
No.
because the
Yes.
gravity on these objects is so weak.
it could have its own little moon.
OSIRIS-REx, like Hayabusa, is a sample return mission. So it, at some point, is going to go down, has an instrument called TAGSAM
Mm-hmm.
that is
Touch
going,
and go sampling mechanism.
awesome, that is going to blow a puff of nitrogen gas at the surface, kick up some of that sweet, loosely bound regolith,
Mm-hmm.
and capture it in a little dustbin,
Mhm.
basically, and send that back to the Earth.
Do you think they're pretty worried after those Ryugu images, though? Because the Ryugu images show that, like,
Super
it's
rocky.
big boulders.
Yeah.
It's not just little tiny particles. So they're expecting, like, centimeter-sized particles probably for Bennu. And the two bodies are very different sizes, so you might expect different particles, but, like,
Bennu being bigger than Ryugu.
I think so.
And if you go to the moon, you look at the footprints of Neil
We'll be doing
Armstrong,
that soon.
very dusty, so
Yeah.
lots of fine-grained dust on the moon. So this kind of sampling would totally work on the moon. As you get to a very, well, you get something.
Yeah,
you
you
blow
get
up off, the stuff would blow up. We know that from
Yes.
the rockets land there and they blow dust around. But on these tiny asteroids, because the gravity is so weak, some of these weak forces that we've been talking about, like light and electrostatic forces, can actually dust them off, essentially.
Ryugu is bigger than Bennu.
Ryugu is bigger than Bennu.
Mm-hmm.
Okay.
So we might expect even bigger stuff on Bennu.
So you might, or to put it another way, less dust.
Less dust because it's all been poofed off.
So that could be a problem.
Because it could be a problem. So the way that dust comes off is the same thing that makes dust stick to your TV. Those same forces can cause dust to fly away from the surface of an asteroid. If it gets off the surface at all, those electrostatic forces can move that dust around and get cleaned off because the gravity is too weak to make it fall back down.
Weak gravity.
So it'll be very interesting to see. Meanwhile, Hayabusa 2 with its family of
They've had a bunch of little landers already, but they postponed their main sampling touchdown till they were going to try to do it before the end of the year. But they postponed it till next year because the surface was so much more complicated than they expected. They were like, all right, we're going to do a little bit more mapping and do a couple of test runs before we do the real thing to be nervous because it's nervous making.
Nervous making.
Yeah.
That's so exciting.
So, did they know that these things were rubble piles before they launched to them?
Sure.
Yeah, we knew they were rubble piles, but that doesn't mean it couldn't have like a more of a regolith coating.
Right. But I'm just wondering why they look. I mean, when we look at all the other asteroids we visited, places like Eros and Matilda, I don't know, these other, they don't look like this diamond-shaped rubble pile thing.
Right.
No, but like
They have much
Inokawa
more-
looks like a weird potato.
It looks like a weird potato, but not like it's weird that the two places that we're going for sample return missions at the same time both happen to look
like
almost the same.
They're also similar composition, and which is different than previous asteroids we've been to, I think. So that's interesting.
And it seems weird to have chosen those because we know, like you could see the regolith on some of these other asteroids that we've been to, like Eros
Right.
and things like that.
So
it seems
Eros
like
is much
that
bigger.
kind of a thing would be a safer choice.
Well, the reason it wasn't necessarily an option, so you have to have the orbital mechanics line up for you to go to these things to be able to get it.
And also
the energy has to work out for you to be able to get there, get something from it, and then bring it back to the Earth is a much bigger challenge than just going there.
For sure.
yeah, and also like they wanted to go to Bennu and Ryugu partly because they are different, like compositionally, and they're different location, different compositionally, and we think that they might be more interesting in terms of like ISRU things, so using the resources from those asteroids, but also like fundamental science understanding where they came from. We'll post a little picture, but here's a little like scale picture, right? So there's Eros, there's Matilda, here's Bennu.
Addie's pointing
I
at
am.
pictures.
So like, it's
Very
much,
helpful
it's
for
much,
that. Oh,
I
but
said
if this was
we'll
on
post a
YouTube.
picture.
Well,
I could be like, ooh, look at
As you're
that.
driving and listening to this podcast, just pull up Facebook on your phone and take a look at the picture Patty posted.
Don't listen to him. He's giving terrible advice. We do not condone that.
Yeah.
Jim, you said you were going to get worked up about
I was getting worked about something else.
Oumuamua,
No,
or-
more
No,
dust things.
It was the other
Dusty
dust thing.
moons.
Let's hear it.
Well,
worked up.
Let's set up the story
no.
first.
Get worked up,
Since
Jim.
Addie loves dust and moons, we'll let her set this thing up, and then
Oh, gosh.
I'll rant possibly.
So there was a thing that came out. I read it in National Geographic, but there's a new paper that came out by some authors that it's like very.
Has to do with orbital mechanics again.
It does, but it's a very suggestive title. I don't know, lucrative title. Earth has 2 extra hidden moons, air quotes around moons.
Yeah.
I mean, yeah. It's
It's
basically
clickbait.
it's a clickbait because it's basically an orbital mechanics thing where like there's a bunch of dust. So let's set this up. There's a bunch of dust in space. Turns out we know that, and a lot of that dust gets into different orbits. So like when we run into like meteor showers, right? That's because we're running into dusty debris that's in certain orbits that have been captured from comets and stuff like that, right? So I think I only briefly read the article, but basically this is like what they're hypothesizing is dust that's been trapped in certain resonant orbits around the Earth, and so sort of forms sort of dust clouds. I wouldn't call them moons. I would call them dust clouds.
I definitely would not call them moons either.
Yeah, that was the rant. I'm glad that we're all going to go on the same rant here.
Yay!
So it's like,
Let's rant
they're not
together.
because in
In
the
fairness-
articles that I was reading, they were calling them like objects.
So-
Like this cloud of dust is an it's not an object
A
in
cloud
any
is
way,
an
shape, or
object.
form. Yeah, but clouds are a cloud on Earth is like a thing that is kind of like held together. It's one kind of a unit in some sense.
I don't even know,
think.
but would you even refer to a cloud in the atmosphere as an object?
Yeah, no, I don't think I would. But I certainly wouldn't. This is just like there happen to be places where orbits are fairly stable, and so
Right.
things will generally
So-
collect there.
So let's be fair to the authors.
Okay.
So their
Yeah,
papers
yeah, I'm not. It's not the authors. It's
monthly
the,
notices of the Royal Astronomical Society, and the
And
title
brass.
of their paper is Celestial Mechanics and Polarization Optics of the Kordylewski Dust Cloud in the Earth-Moon Lagrange Point L5-1, three-dimensional celestial mechanical modeling of dust cloud formation.
And that
well,
one
that
is
is
because
a
they're supposed to be
sexy title.
That's the title. And one is because the first paper is just the modeling, and there's supposed to be a second paper that comes out with actually the polarization observations.
Uh-huh.
But so it was confusing also because this is just modeling so far. Supposedly they have observations, but I haven't actually seen that paper.
There have been observations. So, and there was even a cloud of dust in a resonant trap
Mhm.
in a zodiacal dust cloud, with asteroid dust debris that migrates in towards the sun. That's been known for some years.
Is it the
that's been
Kordylewski dust
observed.
cloud?
I had never heard it referred to that way. I
Maybe
know
it's
about
because
it.
you're not in Eastern Europe or Russia.
I knew about it from papers by Stan Dermott, or a colleague at the University of Florida. So these little tiny forces that push things around can cause dust to drift in towards the sun, and as it does, it can get caught up by sort of little miniature gravitational traps
Right.
associated with planets.
Yeah.
And the Earth has some,
Mhm.
and some of our sort of survey space scanning satellites can map the distribution of dust in the sky and been able to see, oh, there's a concentration of dust in this particular location. It's moving along with the
Aren't
Earth around the
L4
sun.
and L5 where the Trojan asteroids around Jupiter are?
Yes.
Right.
Yeah, so these
Right.
are like
These are called
these
Lagrange points, right?
points. So
That
that's
are-
what L5 in the title refers
Yes.
to,
Right.
Lagrange point number 5. So it's like, yeah, these weird gravitational areas in an orbit around a planet or around the sun or whatever, where there's like sort of, it's like if you have a little dip in a surface and water collects there. It's that kind of thing.
Right.
And this is, it's useful information to know about because we do like to do things like sometimes put our satellites in those places because they're fairly. That is, that you put a satellite there and it kind of stays in the same position relative to the Earth and Sun. So we like to put.
James Webb is not going that far out.
It's going to L2, I want to say, or 3. It's not going to those particular Lagrange points, but it's going to a Lagrange point. So it's a similar.
Discover, the one that takes images of the Earth, that just takes full disk images of the Earth, is at L2, I think? Because
That's
I
the
think
one that's in between the Earth and the Sun.
it's the one that's past the moon. Or in between, no, it's outside of,
It's towards.
it's in one of the ones.
It's towards
L1
the
or
sun.
L2. That's L1 then.
It's towards the. I mean, if it's taking pictures of the Earth, it wants to be
That's true. So it's
with
an
the sun
L1
at its
probably.
back, basically.
Yes,
Yeah.
yes. It's an L1.
There are 5 of these points.
Yes.
We were talking earlier about things named after famous scientists that passed, like Lagrange points and Stokes' theorem. And,
Yeah. This was
things
earlier
like
in
that.
our lives, not in the podcast.
Right, earlier in our lives today.
We have really scintillating conversations during
Yeah.
And
Nerds.
we were pointing out that there weren't many things, at least none popped to mind, of like the Smith theorem.
There's
or
Hill
the-
sphere.
Hill sphere, okay.
Hill
Yeah,
radius. That's the only one I've thought of though. But there's no
That's-
like Jones or Smith.
Jones and the Johnson.
There is like a Jones
criterion.
potential in like molecular.
Leonard Jones.
Leonard Jones potential. Yeah,
Yeah.
but that's not one dude Leonard Jones.
Right.
It's like Leonard Dash Jones.
Right. It's because Jones, like, they're never going to call this after me because my last name's Jones. I need to find somebody else with a more memorable name attached to it. So,
What's your rant, Jim?
that's
No,
it.
that's
It's
it.
just it's not a moon.
That's no
it's
moon.
not an object. It's just like a collection, a bigger, more
Well, this-
dust than the average place because
You know what would be
it's the place
super
that dust
interesting
collects.
to try to send to that?
Yeah.
A little
Fly through
dust
it.
detector CubeSat.
Yeah. But this illustrates how something
Easy
with
it
such
is.
a mundane technical title gets
Yeah.
transformed into the Earth has 2 new hidden moons,
Yeah.
just confirmed by
Which
a
again
paper from
It's frustrating, but also
It's cool
not
because
bad because it gives
intrigued.
people right. Because you're not with that sexy title you read a second ago.
It was
Nobody's
so sexy.
ever going to read that in the general public, right? And
Maybe that's okay though. I mean, isn't there a Cry Wolf danger
Yeah,
here
sure.
Mhm.
with some of this stuff.
Yeah.
With like,
There is.
oh, 2 new moons. And then you read, it's like, what's that? Let me go check out what the Astrocorps say on Walkabout the Galaxy. Oh, they
it's
call
not.
BS.
Yeah, that's what we're here
I guess
for.
that's true.
Yeah,
If there's things you have questions about that are clickbaity titles,
that's right.
definitely send them to us
Yeah,
so we
right.
can
We will rant
debunk
about
or be excited about them.
Okay, you guys ready to take a crack at the trivia?
I'm
Yes.
so ready.
Okay, Jim.
them. I forgot there were like 3 questions.
As of October 28th, 2018,
Yeah.
so that's after the launch of Addie's CubeSat.
Okay. So add Eddie's CubeSat to the answer. Or to one of the answers.
I know you knew how many there were,
So add
minus
one.
Addie's. Go ahead and add 1 for Addie's.
Okay.
How many CubeSats have been launched as of
Okay.
October 20th, 2018? That's the question I'm actually asking.
Oh, it's tough to say because they launched in like bunches.
Is that why it's tough to say? Or is it because you have no idea how many it is?
1,000.
Okay. Addie's nodding grudging approval to that guess.
Total?
According to that
Okay.
European database, how many CubeSats, and they said CubeSat is 0.25 to 27U. They had I will tell you, a slightly higher number for something they called nanosats,
Yeah.
which
Are bigger than CubeSats.
it was weird. It
It's very
sounded
confusing.
like their definition of nanosats was CubeSats plus some other things that I could not get a clear definition
Yeah,
of,
there's these other spacecraft
So-
called nanosats that are actually bigger than CubeSats.
which makes
But
no
they came
sense because
first.
of nano.
Yeah,
I think
Right.
they came first in the naming, so they were called nanosats, but
In any
they're
event,
bigger.
this
than
refers to
27U.
CubeSats from 0.25 to 27U.
I want to say it's like 870 something.
Addie nails it.
Nice.
Impressive.
Yeah?
878.
Nice.
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 I hadn't looked in like a
I'm gonna
month,
give myself
so
some credit too, though.
You
'Cause
did
I was
quite well.
like
That's
order of
why I was
magnitude
impressed.
correct.
Yeah, that was.
I could have
that was
easily
good.
guessed 10,000 or 6.
That's true.
You weren't going to guess 6.
Probably not 6, but I could have easily guessed like 20.
Yeah. So the crazy thing is,
No.
so those
No,
numbers-
I've been to a talk or two
Okay.
by Addie, so
That's
So-
true.
How many are expected or scheduled nominally to be launched in the next 6 years? Ballparkish. Looking for one or two significant digits here.
Oh, jeez.
Probably like
So that 878, when were the first ones launched, Addie? I don't know this, but you
2006.
do. Okay.
Okay, so how many years are you talking about?
Next 6
Next
years.
6 years?
So the first 12 years had about 1,000. Next 6
4,000.
Yeah, I would say like 5,000, 2,000, 2 to 5,000.
You're both right, somewhere in that range.
All right.
Yeah.
Hey!
Yeah.
It's a lot because there's a lot of these constellations that are starting to go up, and there's also a big backlog because
Right.
there's supposed to be these nanosatellite launchers that are coming online, and it's been slow to get them online.
Gradually
So,
coming up online.
but they're coming online, so
And
there'll
they
be a
do
lot more
launch them,
launches.
as Jim said, in bunches.
I think you
So
had a question that you
Those,
didn't ask,
those,
I did.
which was how
'cause
many
were you
don't
peeking at
survive. No, you asked it, and then
Oh, how many nanosats destroyed on launch?
yeah.
And
That's a
how
sad
many
question.
countries have launched
Ooh, that's an
nanosats?
exciting question.
That's a lot of questions.
That's
I was going to say I was
There's
actually
like
impressed with
20
the number of
countries.
nanosats given how much work I've seen you guys put into like two not nanosats.
Yeah, they
CubeSats.
are. They're
Two
CubeSats.
yeah.
And I'm wondering how many people are there around the Earth building
Well-
CubeSats? The answer must be a lot.
There's a lot.
Well, let's start with, instead of how many people, how many countries have done
How
it?
many countries? 5 countries.
I think it's like 20.
58.
Holy
Wow.
cow!
Nice.
So that's the idea behind these things, is small satellites,
Yeah, you can do it.
cheap to
Yeah.
build, cheap to launch. The number destroyed on launch, 86,
86.
It's lower than I
which
expected.
is lower than I expected. The number that
The
failed.
sort of like mortality rate though, the sort of early death rate of like maybe
Well,
they
like-
never even talked to is close to like 40%.
Yeah, I was going to say
45%,
45%, but
yeah.
somewhere in that. Yeah.
So,
Ouch.
but it's slowly skewing better now.
Right.
So
The earlier ones had a much higher failure rate than the
Yeah.
more recent ones. Jim, I want you to talk about this science fiction thing that you guys were talking about before we started recording, because I don't know anything about it, and our listeners might be interested in Hyperion.
Hyperion.
Yes.
Hyperion. Well, we're talking about this because you mentioned that Arthur C. Clarke classic book, which I had not heard of
Rendezvous
for some
with
reason.
Rama,
even
which
though-
relates to Oumuamua, so this is all totally within scope of the
Totally,
show.
yeah.
This
And
all
so-
totally makes sense and is consistent.
Yeah, and all three of us are science fiction nerds and like to read sci-fi books, and I happen to be reading a book called Hyperion,
Yeah.
Oh, you're reading it now.
I'm reading it now.
I'm
93% done, and it's nice that I
Are
can
you
know
reading
that
it
because
on
I'm
a
on a Kindle, so I know exactly.
And whatever is in Hyperion, you said, is named after Saturn's moon of the same name?
Right, so Saturn has a small moon named Hyperion, and maybe you can tell us more. I mean, all I know about it is it's a small moon of Saturn.
Oh, it's a very interesting moon.
Super
It's
cool.
one
Why?
of my-
What does it do?
Well, it looks like a loofah. I mean, it really looks weird. It's one of the weirdest looking. It was
Yeah.
my favorite moon until we got close-up pictures of Pan,
Pan, right.
which looks like a ravioli, and it became my favorite moon because I like ravioli better.
Sure.
But Hyperion is much bigger. It's a spongy-looking moon, and it turns out to look spongy because it's very low density.
Right.
And
Just
that
like
means,
a lot of our asteroids.
yes.
Oh.
And so it's so when things hit it and pulverize it, most of the pulverized stuff goes away, and so you end up with this pulverized, low-density, loofah-looking moon. But there's more.
There's more?
There's more.
There's more interesting than that?
Hyperion has a chaotic rotation state.
Ooh,
What
so
does
do
that
I
mean?
sometimes.
Explain.
I've seen that.
Yeah.
It's awesome. Most moons are in what's called a synchronous rotation state. So the Earth's moon, we always see
They
the
have
same face.
orbital mechanics.
There's an orbital. An orbital's lunar mechanics
Mm-hmm.
is they're synchronously rotating, which means one face of the moon is always pointing to the planet,
Just like
Right.
our moon.
just like ours.
Right.
And that's because of tidal forces between the moon and the planet.
Yeah.
Hyperion's spin is unpredictable.
What do you mean unpredictable?
I mean that you can't predict
If I know what it's
what
doing today, I don't know what it's going to be doing
at
2
some
months
point
from
in
now?
the future. I don't know how far in the future we'd have to go before you could say you don't know what its spin state would be.
Oh.
But its spin state is chaotic, and it's because of perturbations from nearby moons and because it's oblong. And you know how there's this really cool aspect of rotating objects that I have seen, I demonstrate it, I can't say that I fundamentally understand it, which is embarrassing because it's a basic physics, mechanics problem,
Yeah.
which is that an object like a Lego brick, something with a long and a short and a middle length.
Yeah.
Oh,
it's
so like a
rotating-
2x4 Lego brick, not a 2x2 Lego brick.
Good clarification. I
Yeah.
stand corrected.
Okay.
I stand clarified. You take a 2x4 Lego brick and rotate it, spin it around the intermediate axis, around the axis that's on the intermediate length, it tumbles in a weird, funny way.
Wow.
And Hyperion is like a Lego brick.
Is that why kids are always like knocking Legos over because they want to see if they have chaotic tumbling?
It is. I'm sure that's
So
why
when you
it
say
is.
chaotic tumbling, do you mean actually mathematically
Yeah.
chaotic
Yes,
Yeah.
tumbling?
it is mathematically chaotic tumbling.
That's awesome.
Jim's actually interested
So
now.
mathematically chaotic means
I'm biting. You got me.
that you can't.
You had to tell him it was math chaos, not just word
That's right.
chaos.
No, but like chaos
It's
could
not-
just mean
it's-
it's hard to predict
It's not
because
it's not just that it's complicated.
Yeah,
it's
yeah.
that you truly cannot say how
That-
that moon will be rotating at some point in
I'm
the
in.
future.
I'm in.
So
Now
what
I
about
like the book even more.
Tell us
Even
about
though
the book.
well, the
Tell us
book-
about
The book has nothing to do with
The book
chaos
has nothing to do with
rotations.
Hyperion, although I believe that I read that the book's name was taken from the moon of Saturn, but it's a sci-fi classic.
Mhm.
It does connect with what we were talking about last episode because there's a lot of sex in this book.
Nice.
There's some sex,
Okay, yeah, not a lot of
but
sex.
some alien sex.
Is it true?
Yeah, there's some alien sex. There's this awesome soldier guy that has some crazy awesome sex with like this very evil alien that ends up killing like everybody. Anyway, it's. I'm not gonna spoiler alert everything. I don't know. You know, this was. If that's all possibly a dream sequence, you don't know. You're gonna have to wait and find out. And I can't spoiler alert it.
So-
I'm only 93% done.
So Hyperion is a
I
pretty.
think you
I think you
could
could still
spoil
spoiler
it.
it.
I can spoiler something.
Yeah,
But I don't know
it's
what's
a very
gonna
good. So it's the first in a series. There's actually a series of the novels by Dan Simmons and Hyperion. It's a really good book. So I don't read a lot of sci-fi.
We
but
should
I read
take him
this
on the
book.
show.
I
You
read
should.
this book and I was like, I loved it. I read it through it really quickly, and like there's a follow-up called like Fall of Hyperion or something. And there's a couple of other ones in there. It's a
Alright.
really good series.
Okay, so kinky alien sex and a really good sci-fi in Hyperion.
Yeah.
I mean, there's
And-
also in Hyperion. It's just a lot of like. I feel like there's a lot of like sort of human.
It's a neat book because it's. So have you ever read the Chaucer book? What am I talking about?
Oh, the
first book, the
the
Canterbury
Chaucer,
Tales.
Canterbury Tales?
Yeah.
Is that the one I'm talking
I
about?
don't know. Maybe
That's
Yeah.
the only Geoffrey Chaucer.
that's
Yeah.
that's really the only one. That we
It's
know
like
about.
that, like a whole bunch of stories of individual, like little vignettes, but they all link together with
Okay.
one
Yeah.
common thing.
Can you Oh yeah.
Which are it's
Can you
nice
name
because
a-
then you don't have to like read the whole book at one time to you can follow the one vignette and read that and then wait a week and read the other one and it's okay.
Okay.
Can you
So it fits in
name
your
a-
attention span. is
Fits
what
in
you're
mine,
saying.
yeah, exactly.
Can you name a movie that came out in the last, well, now it's probably 20 years, but that features Chaucer in a role?
No.
Certainly not.
The movie A Knight's Tale.
Forgot that.
It's a good movie.
Well,
Sure.
while you may still be groaning about our sponsor,
Oh,
this
I forgot
does
about that.
conclude another episode of Walkabout the Galaxy. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com where you can also see our new WTG t-shirts. We're coming to YouTube where you can see our all-important hand gestures.
And Jim get really excited about chaotic orbits.
I am super excited about it.
Chaotic
I-
rotation states. Chaotic rotation
Oh
states,
yeah.
yeah.
Sorry.
Yeah, his mind is more speechless.
I'm on.
He's speechless. Follow us on Twitter,
At walk_the_galaxy.
where you can ask us questions and suggest topics that you'd like to hear us discuss. Our theme music was composed by Richard Drusick. Catch up on old episodes wherever you get your podcasts and write us a review and then shout it through a megaphone at the speaker's corner of your nearest college campus. I'm Josh Caldwell.
I'm Maddie Dove.
I'm Jim Cooney.
We're the Astropork signing off until the next episode of Walkabout the Galaxy.
Regolith!